Okay, so we're going to start discussing circles, which is section 9.3 in your book. We're going to write the equation of a circle, and we're going to give an equation of a circle and label the radius and center. The formulas that you're going to need here, you might need midpoint, you might need distance, but for the most part, you just need to have a good understanding of what a radius is. So here is our first example, and this is the equation of a circle, something that you've definitely seen before, but the center is based off of, in this format, the center is based off of this value and this value, and our radius is based off of this. The center in this problem is -2, +3. So what we're basically doing is we're setting each of these parenthesis terms equal to 0 and solving, and we get our center and how it is shifted from the origin. So this would shift 2 units to the left, and this would shift 3 units up. Our radius is the square root of that last value, which would equal 4. And so we know where the center is, and we know what the radius is, so we could use this to graph it and draw the circle. And as we saw in the previous section, we would solve these guys for y and graph it on our calculator. This is a lot easier if you remember these patterns and these basic principles of these different equations that we're going to talk about. So the next slide here is just going to be the general equation. And so what we see here, this is standard form. So h and k right here is the center, and r is the radius. Not something new, but the one thing that you need to understand is that we use h and k to discuss the center of the circle. So h is the horizontal shift, and k is the vertical shift. And remember, we're always opposite of the symbol. So if we think of h and k as numbers, we would use the positive value of h and k because we've got a minus in the standard format right here. The standard format is always going to have a minus for both of them. So then that means if I had a circle that was centered at the origin, so this would be centered at the origin, because there is no h or k listed. So when we don't have any numbers there, we know it's centered at the origin. And notice this is our format for Pythagorean theorem or distance formula. And so what the center or this equation gives us is distance from the center to the edge of the circle. So it's a distance formula. To our first example, we want to write the standard equation of a circle whose center is at the origin and whose radius is 4, and then we're going to sketch the graph. So it'll be a quick graph, and I'll do it by hand, but the center, so h is equal to 0, k is equal to 0 because it's at the origin, so there's no shift. So if I wanted to look at the standard equation, I would have x minus 0 squared plus y minus 0 squared is equal to 4 squared. We really can skip this step. We just know it's x squared plus y squared is equal to 16. And so to graph this, I'm just going to draw my grid. And what I do is, it's not the nicest graph. On your tests and quizzes, you'll have nice little graphs there that are to scale, and you can, make a much nicer picture than I'm probably going to draw here. I know my radius is 4, so I just go out and count 4 units from the center in each direction. And then I'll do my best to draw what's supposed to be a circle. And there's our graph. And that's it for dealing with circles. And we'll do a couple more examples and a couple different problems that vary from this. But that's pretty much it. Circles are pretty easy. You've seen them before. You know how to work with them. And this is going to carry us through to some of the other shapes, because ellipse is another shape that's similar to this, but remember, it basically has like 2 radius that are different from each other. So the vertical and horizontal shifts would be different. They wouldn't be the same value.